Hello everyone, I go by the name Eden, and I've designed an Arduino project that uses the analog light function to display the brightness of an LED on a serial monitor. Let's set the world.
Okay, so now let's explain the code. So over here we have this line of code, which is the constant let pin equals 9. So this line over here declares a constant integer variable let pin and assigns it the value 9. So this means that the LED is connected to digital pin 9 on the Arduino board, and the const keyword indicates that the value cannot be changed later in the program. So we move on to the next line, and we have bool names prompt that is equals to true. So over here, this line declares a boolean variable that's names prompt, and it initializes it to true. So it means that this flag is used to determine whether the program should display the prompt for user input in the serial monitor. So let's move on. We have the voice setup, and the voice setup function is called once when the program starts. It initializes the serial communication and sets up the LED pin. So under it, we have serial.begin 9600, and this line over here is going to initialize serial communication at a baud rate of 9600 bits per second. So over here we have pin mode, bracket open, LED pin, output. So this line over here, it configures the LED pin, that's pin number 9, as an output pin, allowing it to control the LED. So the subsequent serial printf over here, print ln over here, is a statement that prints initial instructions to the serial monitor, guiding the user on how to use the program. So in other words, we can say that this thing over here, with the help of the print ln, is going to display this words over here to the user, allowing the user to gain access to the code. So we move on to the next line of code, which is the void loop function. And the void loop function is going to run continuously after the setup function. So this is where the main logic of the program resides. So let's move on. So we have if needs prompt, this line over here. Yes, so this block checks if the needs prompt is true, and if it is, then it is going to print enter percentage to the serial monitor and set the needs prompt to false. So this is going to ensure that the prompt is displayed only once until the user provides input. So now let's move on to the if serial available function. So over here, this line is going to check if there is any data available to read from the serial monitor. That is the serial.available bracket close. So it is going to return the number of bytes available to read. So if it is greater than 0, then it means that the user has entered some data. Okay, so over here we move on to int%, and we have serial.sparse int bracket close. So this line of code over here, it reads an integer value from the serial input using serial.sparse int close brackets. So in other words, you can say that it reads characters until it encounters a non-numeric character. So the value is stored in a variable %. Okay, so now let's move on. We have over here this line of code, and this loop actually clears any remaining characters in the serial buffer. So it is going to ensure that any extra characters, like let's say a new line or a carriage return, like do not interfere with the future reads. Okay, so let's move on. So we have if bracket opening % is greater or equal to 0, that's you're comparing it with % less than or equal to 100. So this line over here is a condition that checks if the entered percentage is within the valid range of 0 to 100. So under it we have the int brightness, that's is equal to map % 0, 100, 0, and 225. So this line over here uses the map function to convert the percentage value, that's from 0 to 100, to a PW value, that's 0 to 225. So this map function over here, it takes 5 arguments: the value to the map, the input range, that's 0 to 100, and the output range, that's 0 to 225. Okay, so let's move on. We have this line of code over here, and this block checks if the percentage is 0. So if it is, then it turns off the LED by setting the pin to low using digital write close bracket. So if the percentage is greater than 0, it sets the LED brightness using the analog write close bracket, which sends the PWM value to the LED. So now let's move on. We move on to serial print. The serial print section. So this line over here, it prints a confirmation message to the serial monitor, indicating the current brightness percentage that has been set. Okay, so under it we have else. We have this line of code over here. We have this line of code over here, and this line of code means that if the entered percentage is not within the valid range, that's from 0 to 100, this block prints an error message to the serial monitor. So under it we have this line of code, that's the latter part, and it simply means that after processing the input, the miss prompt flag is set back to true, indicating that the program is ready to prompt for the next input. So the delay under it, that delay 200, is going to add some small delay to stabilize the serial communication and prevent rapid looping. So in summary, we can say that this code is going to allow us to control the brightness of an LED connected to pin number 9 by entering a percentage ranging from 0 to 100 on the serial monitor. Thank you.
Okay, so as I said earlier in the explanation of this code, the main goal over here is to display the brightness of an LED ranging from 0 to 100. So over here, we've run the code and we are going to input from the range of 0 to 100 so that our LED will be displayed. So now let's try the number 20. So as you can see, okay, so now let's move on to, okay, so for clarity's sake, let's change the number to 100. As you can see, the brightness has increased. So now let's decrease it by 10. As you can see, the LED has been decreased. Okay, so as I said earlier, this project should display the brightness of an LED ranging from 0 to 100 on a serial monitor. Thank you.